Hello students, so today we are going to start with the second chapter of geometry, that is Pythagoras theorem. The statement of the theorem is, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Mathematically it can be written as in triangle PQR, angle PQR is 90 degree. So side opposite to that is PR. So PR square will be equal to the sum of the squares of remaining two sides. Now remaining two sides are PQ and QR. So PR square is equal to PQ square plus QR square. The next topic is Pythagorean triplet. Now what do the Pythagorean triplet says to us? The Pythagorean triplet says to us that if there are any three natural numbers, then the largest number, square of largest number is equal to the sum of the squares of the remaining two natural numbers. Then the three numbers are known as Pythagorean triplet. If, for example, in the triplet 11, 60 and 61, number 61 is the largest number. So square of that is 3721. Now sum of the other two numbers, that is 11 square plus 60 square, that will be equal to 121 plus 3600. So the sum of that is equal to 3721. Now the square of the largest number is equal to the sum of the squares of other two numbers. So 11, 60 and 61 are Pythagorean triplet. The square of the larger number is equal to the sum of the squares of other two numbers. So, few Pythagorean triplets are 3, 4, 5, 5, 12, 13, 8, 15, 17, 24, 25, 7. Numbers in the Pythagorean triplet can be written in any order. We will go with one more example. So the example is 4, 9, 12. Now square of 12 is 144 and the square of other two number, that is 4, 9 and 4 and 9, that is 16 plus 81, that is equal to 97. Now the square of the larger number is not equal to the sum of the squares of other two numbers. Therefore 4, 9, 12 is not the Pythagorean triplet. So few examples are there that you have to solve in the given exercise. We move on to the next topic, that is 30, 60, 90 theorem. The statement of the theorem is, in the acute, if the acute angle of a right angle triangle is 30 and 60, then the side opposite to 30 degree is half the hypotenuse and the side opposite to 60 degree is under root 3 by 2 the hypotenuse. So the given part is triangle ACB is a right angle triangle in which angle CAB is 90 degree, angle ACB is 30 degree and angle CBA is 60 degree. What we have to prove here is the side opposite to 30 degree. Now angle CAB is 30 degree. So side opposite to that is AB. So AB is equal to half the hypotenuse, that is half of BC. Next part that we have to prove is side opposite to 60 degree. Now side opposite to 60 degree is AC. So here AC will be equal to under root 3 by 2 the hypotenuse. So here we have to do certain construction. Here you have to take a point D on ray AD such that AD is equal to AB. Okay. Now we will start with the proof. Here AB is equal to AD. So this is by construction, and so we can say that AB is A is the midpoint of DB. Okay, as A is the midpoint of DB, and from A a perpendicular is drawn, so we can say that AC is a perpendicular bisector of BD. So here C is equidistance from D and B. This is by theorem of perpendicular bisector. From this we come to the conclusion that BC is equal to DC. Okay. Now in triangle DCB, okay, DCB angle DBC is equal to angle BDC. Angles opposite to the congruent sides are congruent, and here DBC is given to us as equal to 60. So naturally angle BDC will also be equal to 60. Now one of the angle is left, that is angle BCD, that will be equal to 60. From here we can, now all the three angles are 60 degree, right? So from here we conclude that triangle DCB is an equilateral triangle. Now here, as it is an equilateral triangle, so all the three sides will be equal. So DC is equal to BC is equal to DB. Now AB is equal to AD. So here AB will be equal to half of DB, right? Now DB is equal to BC, so I can write AB is equal to half of BC. So this is what is the first proof of our theorem. Now for the second proof, we have to go to the right angle triangle. So the right angle triangle over here is a triangle ACB. So by Pythagoras theorem, AB square plus AC square is equal to BC square. Right, in place of AB square, I can substitute BC, half of BC. So the equation turns out to be half of BC square plus AC square is equal to BC square. Now 1/4 of BC square plus AC square is equal to BC square. So that 1/4 of BC square will take to the other side. So AC square will be equal to BC square minus 1/4 BC square. When I solve this, it is equal to AC square is equal to 3/4 BC square. So when I take the square root of both the sides, I get AC is equal to under root 3/2 BC. Now the next part of it is 45-45-90 theorem. Now in 45-45-90 theorem, the statement is as such: if the acute angles of a right angle triangle is 45-45-90, then each of the perpendicular side is 1 upon under root 2 times the hypotenuse. Now the triangle given over here is triangle PQR. Given part is triangle PQR is right angle triangle. Angle P is 45 degree, angle R is 45 degree, and angle Q is 90 degree. Okay. What do we have to prove here? We have to prove that perpendicular sides. Now perpendicular sides are PQ and QR. So PQ is equal to QR is equal to 1 upon under root 2 PR. This we have to prove. Now the proof goes as such: in triangle PQR, angle P is equal to angle R. This is given to us. Now the base angles are equal. So from this, what do we conclude? we conclude that the sides will be equal. Okay, side opposite to them will be equal. So PQ will be equal to QR. Okay. Now on a triangle, as it is a right angle triangle, we have to apply Pythagoras theorem. So here PQ square plus QR square is equal to PR square. Now in place of QR I can substitute PQ. So it will be 2PQ square is equal to PR square. Now PQ square will be equal to 1 upon 2 PR square. After taking the square root, PQ is equal to 1 upon under root 2 PR square. Now PQ is equal to QR. So PQ is equal to QR is equal to 1 upon under root 2 PR. So here we conclude with today's session. We have completed today Pythagorean triplet, 30, 60, 90 theorem and 45, 45, 90 theorem. Hope you all have understood. So thank you.